up, guys, and welcome to Unit 1, Lesson 1 of the How to Linux series. In this lesson, we will be covering Linux file permissions. As always, don't forget to smash that like button and please drop a like. And let's begin. So, for this lesson, the terminal commands that we will be using are echo, which is a built-in command, and as seen in the example here, it will write a given parameter to standard output, aka the terminal window. And the key command for this lesson is CHMOD or CHMOD. It is another built-in command, and it will change the access mode of a file given permission options. Here in an example, we have CHMOD, the options, and the files or file name. And another command we'll be using is nano, which points to a built-in text editing program. And I would recommend using nano compared to other text editing command line software like Emacs or V, because it just has more features. The most common usage for this command or this program will be nano and then the file name. And another basic command we'll be using here is ls. It is a built-in command, and it will print contents of a given directory, or if not specified, the current directory. You see there ls options and directory names. How file permissions function in Linux. Basically, file permissions are separated into three categories. We have read, which is the ability for a user to read/view the contents of a file. An example of this would be reading a file with nano. We have write, which is the ability for a user to edit the contents of a file. An example of this would be writing to a file with nano as well, but not reading, writing it. And finally, execute, which is the ability for a user to execute a file. An example will be running a bash script from a file, which we will cover later. Now, the usage of this in Linux will be most common in the abbreviation RWX. These are binary switches, essentially. Imagine RWX as 111 or 000 or any possible combination. All three of these values can be changed independently. Given these permissions, how may we manage them to properly allocate them in a Linux system? Well, they are organized via the user group others system. Basically, the user, or the owner, is the creator or specified owner of a file, and usually has all permissions to a file. The group is the specified group or groups that own a file. These groups may contain more than one user. And of course, these groups may have all permissions to a file, but it may vary. And the others, or everyone, would specify all users on a system. It is very imperative to be very careful on these permissions because they affect everyone, including people you may not want to access your file. The usage of the system would be abbreviated in UGO. All three of these can be changed independently, and they work in conjunction with RWX to basically map every possible permission outcome in the system. It can be changed in other CH commands such as CHMOD, but we will cover those in another lesson. Now, the start command of this lesson, CHMOD. The command CHMOD can be broken down into multiple parts. First, after you input the command, we have who, which is where you specify either a change in user, U, group, G, or other, O permissions. If you don't specify any of them, then you will automatically change all or A permissions. An example would be chmod space U, meaning you will change only user permissions of a file. Following that would be the opcode, where you would use either a plus, minus, or equal sign to either add, remove, or set permissions. Keep in mind that if you use the equal sign and set permissions, any permissions that you don't specify will be dropped or set to no access. Here we have some examples. CHMOD space U plus, meaning you would add permissions to user. CHMOD U minus, meaning you will subtract permissions from the user. And CHMOD U equals, meaning you will set permissions for the user for any set file. Now following that, we will put the permissions, and that means RWX. For example, if you put chmod u plus rw and then a file, it will add read and write permissions to said file for the owner, since we input u as user. Now, as extra info, instead of doing this human readable RWX system, we can input permissions in binary code to represent every possible user group other read write execute pattern. As an example, we would have CHMOD 777, which will give all permissions to all users. I recommend never using that, ever. And lastly, options can be changed, such as in the examples, CHMOD u equals RW, meaning CHMOD user will be set to read write and execute will be dropped. CHMOD group equals WX, meaning we will set write and execute permissions to group and drop read. And others equals read, meaning we will drop write and execute but keep read for the others or everyone. Now, after all that information, which I hope you took notes on, I will conduct the demo. Make sure to open up Linux shell and follow along. So now that we are in the Linux shell, we can begin the demo. First, let me type ls to just see if there's any files in this directory, which they aren't. Now let's create a file with some random text. Let's say hello world. To do this, we can type echo and then some hello world. And then we can append this using greater than, two greater than symbols, to a file, let's say test. So basically, we will echo and we specify this as a string with these quotes, and then we greater than append into the test file. Type it out, and it has been completed. We can ls again. Sorry, my shell is lagging here. Ls again, and boom, we have a test file. And if you open this with nano, we can see that we have the phrase hello world in this file. Now, as I mentioned in the presentation, we were able to read this file with nano because we had read permissions. So if we use the command ls, and then we put the flag -l, meaning long, and then leaving the next blank, so it's the current directory, we can see the permissions of the test file. We see that we have -rw -r So what do these mean? Well, basically, the first dash specifies whether this is a directory, which it isn't, and the first rwx will specify the user's permissions. The second rwx will specify the group's permissions, and the third rwx will specify everyone's permissions. Obviously, since I'm the user, since I created the file, I have read access, meaning RW. Also write access, meaning I can edit the file. So if I show that here, hello world, and let's say again, and then Control O and nano to write out, enter, boom. I wrote out successfully, Control X to exit, and we're back to the shell. Now let's start actually using the CHMOD command. So first I can type out CHMOD and then specify the user as you, and then we're gonna take away permission with minus, and then let's take away write, and then we can specify a file test, the file we created. It went out successfully. Now if we check the permissions of test with ls-l, we can see that in the user group or the user area of permissions, W is no longer there, meaning we do not have write permissions. We can test this with the nano command. When we type nano test, we can still read the file, but as it says here, we cannot write to it. If I try to edit, and then try to write out, we can see that an error returns, meaning permission denied, meaning we cannot write. So let me escape. Save modify buffer means that if I don't have permission to save the file, it saves like an extra one with my edits. I will say no to that. And now we're back to the shell. Now that we have write gone, let's also remove read. So let's do chmod, user subtract read, and the file. It went through. Do ls-l, and we see that the test file has no read and no write for the user. So let's see if we can read this file in Nano. You may guess that we can't, and yeah, we can't. It does not say any hello world, any again, no nothing. And it says here, error reading test, permission denied. We can just exit out of that and back to shell. And now, let's see if we can use a command perhaps like echo to add text to this file without having to use Nano. Let's echo, I still have write permissions, and then append it to test. Remember, appending is two greater thans. One greater than would mean write, meaning even if you already have a file that exists named test, if you write, it will replace anything that's in it with your new contents. Appending will make sure it does not replace contents. So if we typed it out, we can see that we have permission denied, meaning that write permissions affect all commands that even attempt to write to this file. Now let's test out a bunch of different CHMOD configurations on this test file. First, let's see what we have to deal with. We have only read and read on group and others. So firstly, let's add read to the user with CHMOD u plus r test. And we see it, and it has worked. Now, let's make it so that we can take away read from group and others. We can do this with CHMOD, group other, minus read, and then the file. And boom, now group and others have no read anymore. Now let's make it so that only group has read. So first we can take away group from the user, or take away read from the user for test, l-l, no permission whatsoever, and we can add group to read with g plus r test. Sorry if my shell's lagging here. And finally, let's make it so that we can only have read for the owner. Let's take away read from group and test it there. Now we have no permissions again, and then we use other plus read test, and boom, and now only others have read. Now let's take that permission out again, O minus R, and get back to the clean slate. And now let's do write permissions. Let's make it so that the file only has write permission for owner, or user. So user plus W test, l-l, we can see that. We can take it back away with that, and then CHMOD, do it for group this time, plus W test, -L, we see it has it, and then we can use the arrow keys to go back to the previous commands, using the up arrow key to go back to what you typed before, and the down arrow key to backtrack on what you entered. So let's see, let's change G plus W to G minus W, and now we're back to the clean slate. And finally, let's add write to only the others. So we can change G plus W, and boom, now we only have write for the others. Let's remove that again. And finally, let's change the execute permissions. So for user, it would be u plus x, and then the file name. We see that it works. And we also see that since we added execute permissions, the file lit up green, meaning now we have permission to execute it. Not all shells may have this color though, but most do. So we can take execute away from user. And we see that now we have no execute permissions, that the file does not light up. So none. Let's add execute to group with g plus x, ls, or l/lmn, and we see that it is lit up again because I am the user and the owner of the file, and I'm also the group, meaning permissions for the group also apply to me as the owner. So if we take the execute permission away from group. The light is gone again. And now let's add execute to others. We see that since others is I'm also in the others group, because we can imagine that owners group and others are like a pyramid, upside down pyramid. So others affect everyone, including me. So we can test it out, and yeah, others have execute. Let's take execute away from others. And that is essentially the CHMOD command in Linux. As I mentioned before, we can also use binary code like 777. So by CHMOD 777 test, mind that we don't need to specify group or user or plus or minus, because the binary code is basically already an automatic set for the equal sign, as we mentioned before. And since we have an 8-bit number for every single place here, we can imagine that 0 to 7 is 8 possible values. Now we have user, group, others, and read, write, execute, meaning we have that many outcomes, and they can all be represented in digits from 0 to 7 and 3 places. So that is the end of the demo. And as always, thanks for watching. Please subscribe, and I hope to see you in the next Linux tutorials.